This lesson is for Secondary Math 2. Please title your notes 3-4/3-5 comes from two sections of Chapter 3, Solving Quadratics. The essential question is, how do you solve quadratics and what do the solutions represent? If you recall, we have looked at quadratics in a few different forms. Vertex form allows us to actually see the vertex in the function. Remember, this was vertex, y equals a times x minus h squared plus k, where we can see by the horizontal shift and the vertical shift and go opposite, same, we have the vertex. And we also looked at standard form. Standard form is y equals ax squared plus bx plus c. You can't just see the vertex when it's in standard form like this. So in order to find the vertex, we need to do axis of symmetry, which is x equals negative b all over 2a. And then we plug that in for the y value. Okay? Now both of those functions by doing these steps finds the vertex. Now we're going to learn how to solve finding different points on the graph, which are different than the vertex or the vertices. Okay, and all of these solutions have four math synonyms that you need to get used to. They're called solutions, they're called roots, they're called zeros, and they're called x-intercepts. Because what we're finding is when we have a quadratic, if it crosses the x-axis, those are called x-intercepts. Notice the height of these x-intercepts. If you're sitting on the x-axis, your height is 0, hence why they're called 0. Roots, because since we have a square, because quadratics are squared, the inverse of squaring is taking the root, and they're called solutions because they make the equation equal. Okay? Our first example. Example 1. Find the solutions of. Find the solutions of x squared minus 16 equals 0. Okay, it's just a basic equation, and it's a quadratic equation because of the squared. Actually, zoom that in a little bit. There you go. So you can see that a little bit better. Okay, so to find the solutions of this equation, I would just do my inverse operations, trying to get x by itself. So I'm going to draw an upside down t, and I have a square to move and a minus 16 to get x by itself. So first I'm going to do the inverse of minus 16, which is add 16 to both sides. That gives me a 0 there. I have x squared equals positive 16. Now we have to do the inverse of squaring. The inverse of squaring is the square root, so we need to square root both sides. So the square root cancels out the squared, leaving us with x equals, what's the square root of 16? It's not just 4. It's actually plus or minus 4 because positive 4 times positive 4 is 16. Also negative 4 times negative 4 is 16. I want you on every problem for your homework on this assignment to also plot a graph of what these answers represent. Because what we are getting are x-intercepts. So I want you to solve it, and then I want you to have a visual of what it represents. So negative 4 is right there. Positive 4 is right here. We're going to put x-intercepts right on both negative 4 and positive 4. Looking at the original quadratic, x squared was positive. Remember, if x squared is positive, that's a concave up parabola. If x squared is negative, that's a concave down. So since it is positive, we're going to this is just a rough sketch, but I want you to, when you solve it, know what these answers represent. So I would like you to plot the x-intercepts and either make it concave up or concave down, whichever is appropriate. You don't have to worry about, for this assignment, finding the exact vertex. Okay, next. Instead of writing find the solutions of, I'm going to change up the problem and say find the roots of. Remember, 4 different names. 1, solutions, roots, zeros, x-intercepts. You need to practice those. Solutions, roots, zeros, x-intercepts. No matter what the directions, which one the directions you use, it means do the exact same thing. So for finding the roots of m squared minus 36 equals 0, we're going to solve, just like we did before. So the m squared minus 36, we have a square to move and a minus 36. When you are solving equations, essentially you undo PEMDAS, which means we're going to work backwards. So the majority of the time we do addition and subtraction first. So the inverse of subtraction is add. So we're going to add 36 to both sides, which cancels that out, leaving with us m squared equals 36. Okay, now we're going to undo the squared, which the inverse of squaring is square root. Square root both sides, we have m equals, it's not just 6, it's plus or minus 6. If you apply the square root yourself, you need to write plus or minus. Okay, now we're going to plot this. This creates x-intercepts for us. Now I know it says m. If the m bothers you, you can change all the variables in your assignments to x's. If the different variables bother you on this assignment, just change them all to x's. So they're x-intercepts. 1, 2, 3, 4, 5, negative 6, point there. 1, 2, 3, 4, 5, positive 6, point there. Again, let's look at m squared sine, or x squared, because I scribbled it out and changed it to an x. It is positive. So that is oops, I missed it. There we go, concave up, like that. So every problem after you solve, I want you to graph it so you recognize these solutions, or roots, are actually points on the graph. Okay, now I'm going to change up the directions, but it means do the same thing. Example 3. Find the x-intercepts of, remember, zeros, roots, solutions are all x-intercepts. You need to be used to all 4 of those. Our equation is negative 3x squared plus 15 equals 0. Okay, solving for x. Again, we're going to work with addition and subtraction first. The inverse of adding 15 is minusing 15, both sides. That cancels out, and we have negative 3x squared equals negative 15. Now in this case, we have negative 3 and a squared still remaining. Okay, what's easier to move? If we don't want to deal with irrational numbers, I'm not going to square root yet. I'm going to do the inverse of times. This is negative 3 times x squared, so we're going to divide because that's the inverse of timesing. Make sure you do a negative 3, not just a positive 3. Cancels out. We get x squared equals a negative 15 divided by a negative 3, and negative divided by negative is a positive. Okay, the inverse of squaring is we take the square root. Now the square root of 5 is not a pretty number. So if you're asked for an exact answer and you weren't given directions to round, we would just leave it as plus or minus square root 5. Unless there's directions given to you of how to round, you need to leave it in exact form. For graphing purposes, I have no idea where square root 5 is on the graph, so I would like to know approximately what the decimal is. The decimal is approximately 2.2. So this one here is the exact value, and the squiggly equal sign means approximate. So if I was to graph this 1 to negative 3, 1 to positive 3, because I need to do a plus and a minus, 2.2, negative 2, and negative 3. 2.2, negative 2.2 is right about there. 1, 2, positive 2.2 is right about there. So every time you get these answers, they're representing something on the graph. So every problem on the homework, I want you to do the graph. Okay, now let's look at our x squared. Negative 3x squared. It's negative. That means it's going to be concave down. So, because the negative numbers are down. So I want you to draw a parabola like that. Okay, example 4. Find the, which one have I missed? I've done find the solutions of, I've done find the roots of, I've done find the x-intercepts of, and the last one that's synonymous is find the zeros. Zeros of. Because remember, if you're on the x-axis, you're at a height of 0. Here's our function. 2x squared plus 8 equals 0. Okay, again with addition and subtraction first. I'm going to subtract 8 on both sides. Cancels out, leaving us with 2x squared equals negative 8. Okay, we want to undo the multiplication before we undo the squaring. Okay, so I'm going to divide by 2, because the inverse of timesing by 2 is dividing by 2. 2 divided by 2 cancels out to 1. And we're left with x squared equals negative 8 divided by 2 is negative 4. Okay, the inverse of squaring, again, is the square root. I hope you're picking up on that. So x equals, well, what is the square root of negative 4? I know a square root has to be a number times itself. The square root of positive 4 is plus or minus 2, because positive 2 times itself is positive 4. Negative 2 times itself is also positive 4. What number times itself would be negative 4? And some of you are thinking maybe 2 times negative 2. Well, those aren't the same numbers, so you can't use that. So the number actually doesn't exist in the real world. So it's actually imaginary, which we'll be coming back to when I return. So we do know the square root of 4 is plus or minus 2. So just treat it like that, and then because it's a negative, just stick an I on it. Okay, because it's a negative, just stick an I on it. And the reason it's imaginary is because there are no real solutions. Okay, and the reason there are no real solutions is because there are no x-intercepts. So this graph, I have an A for 2. Remember that multiplier of 2 makes it steeper. It's concave up because it's positive. This plus 8, the constant, is a vertical shift from the origin. There's no horizontal shift because I don't have any parentheses there. So 2, 4, 6, 8. 2, 4, 6, 8. My vertex is at 0, 8, and it's concave up. Will that graph ever cross the x-axis? The answer is no. Hence why we got an imaginary solution. It's still a solution in the imaginary world, but if you're asked for real solutions, our answer would be no real solutions. And the reason there are no real solutions is because it never crosses the x-axis. Okay. Last type of problem. We're going to solve using the zero property. This property is really nice. The reason it's called the zero property is because the equation has to be set equal to 0. And the reason it's set equal to 0 is because we're looking for x-intercepts, and x-intercepts have a height of 0. Okay, right now the equation is actually not in standard form. Instead, the equation is in factored form. These are factors. What I could do is, these two factors are being multiplied. The inverse of multiplying, if I'm asked to solve, the inverse of multiplying is dividing. So if I take this x plus 1, I'm going to actually do this side problem over here. X plus 1, 1, times x minus 5 equals 0. I'm going to show you why this is valid, but we're not going to do it this way every time. We're going to do it the shortcut way. Okay? And since they're timesing, I'm going to solve for one of the x's by doing the inverse, which is dividing by x plus 1. That way it cancels out. Divide by x plus 1. It brings down x minus 5 equaling, well, that's 0 divided by something that's non-zero. That's just 0. So x minus 5 equals 0. What number minus 5 equals 0? That would be positive 5. X equals positive 5. Okay? If I decided to remove, oops, that's a terrible one. I'm just rewriting the same function. If I decided to instead divide by the other binomial, divide by x minus 5, divide by x minus 5, x plus 1 remains. And what is 0 divided by something non-zero? It is also 0. What number plus 1 equals 0? So x would be negative 1. That's the long way. Let me show you the shortcut. When you see two factors set equal to multiplied and set equal to 0, all we're going to do is give it a little squiggle. Little squiggle. And you're going to take the first factor, set it equal to 0. Oh look, that's this step. X plus 1 equals 0. What number plus 1 equals 0? Well, that would be, and if sometimes it's not so pretty, so you actually have to solve it, but that would be negative 1. Check, we got that answer. Okay, now we're going to take the other factor, set it equal to 0. X minus 5 equal to 0. Add 5 both sides. Okay, x equals 0 plus 5 is positive 5. Check. So the shortcut method of just skipping this intermediate step of canceling them out and dividing it away, it's totally legal because as I just showed you, you get both answers correct. So you don't have to do this long method. We'll just do set the first factor equal to 0, set the second factor equal to 0. Now, I would again like you to start to graph this. Well, on my graph, I have now a point at negative 1 and point at 1, 2. Oops, can you see that? There we go. 1, 2, 3, 4, 5. Positive 5. Because my function is x times x, that's a positive x squared, I know it's going to be a parabola. And for our purposes right now, I don't care so much about the vertex. Okay, so we're just going to draw the parabola like so. What I want you to focus on is that these answers represent x-intercepts and the concavity, whether it's concave up or concave down. Okay, the very last problem. Example 6. Find the roots of 2a squared minus 15a plus 18 equals 0. This is different than our problems previously. Our other problems that were in standard form only had 2 terms. How do we solve when there are 3 terms? The answer is factor. Okay, how do we factor a quadratic? We factor a quadratic by our favorite tic-tac-toe method. The first step for factoring is always look for a GCF. 2, negative 15, and 18. Is there a greatest common factor that divides into both 2, negative 15, and 18? Nope, just 1. Do they all have A's? No. So that should always be your first thing you check. So I'm going to set up my tic-tac-toe. I put A, C, A times C, and I add to B. So A is 2, C is our constant, 18. We multiply that, we get 36. And we add to negative 15. So we're looking for 2 numbers that multiplies to 36 and adds to negative 15. Can you think of what those are? Okay, well, they end up being negative 3 and negative 12, because in order to multiply to a positive, they have to be the same sign. Negative 3 minus 12 is negative 15. Okay, remember we put our variable here. Greatest common factor between 2 and negative 3 is 1. Greatest common factor between 2 and negative 12 is positive 2. This column should always be positive. Don't put any negatives there. Greatest common factor between 18 and negative 3 is 3. Greatest common factor between 18 and negative 12. That would be 6. Now, if I look at my columns, 2 times 1 is positive 2. That works. 6 times 3 is positive 18. That works. Let's look at the rows, too. 1 times 3 is not negative 3. So that tells me I need to give that a negative sign. 2 times 6 is not negative 12. So I need to give this guy a negative sign. And the column still works because a negative times a negative is a positive 18. So that's good to go. Here are my answers. Well, my factors, excuse me. My factored form is a minus 6, and the other one is the other diagonal, 2a minus 3. Remember, this is equal to 0. I just converted the quadratic trinomial into factored form. These are factors. They are not solutions. You're not done. When we have factors, we do the 0 property, which is give it a little squiggle, okay, and set each factor equal to 0. So a minus 6 equal to 0. This one is a type of problem you should be able to see and not actually have to show the steps. So what number minus 6 is 0? That would be positive 6. So it's the opposite or inverse sign. Here is minus, so we're going to choose a positive 6. This one's not as nice. 2a minus 3 equal to 0. Okay, we need to solve for a here by adding 3 first, which gives me 2a equals 3, and dividing by 2. A equals 3 halves. For graphing purposes, oops, can you see that? For graphing purposes, that is 1.5. So again, I would like you to graph it. Oops. 1, 2, 3, 4, 5, 6. Always label so we know what you're counting by. There's my graph. Zoom in so you can hopefully see it. And 1.5 is halfway between 1 and 2. Because at the beginning we had a positive 2a squared, so it's going to be concave up, like so. There we go. Okay, the homework assignment associated with this. Every problem, I would like you to, now I'm zoomed in, so let me zoom out a little bit. Find the solutions. In every problem, I want you to have a graph. This graph, I don't care so much about the axis of symmetry or the vertex, but the graph needs to have your x-intercepts, if there are any, and it needs to be correct for a concavity. Is it concave up or concave down? So here's the assignment. Page 149, numbers 1 through 10, and page 160, numbers 2 through 22 even. Again, every problem, even if the book doesn't tell you this, Ms. Gray is asking you to find the solutions and a graph. Even if the directions in the book don't say it a graph, I want the graph of your solutions, which are your x-intercepts, and the correct concavity, whether it's concave up or concave down.